This is JEE Advanced 2025 question where we are given 6 parallel plates and we have to find electric field. The question in portion A, it asks electric field in region 4 and in configuration 1, and electric field in region 3 for the second configuration, and also we have to find the potential difference between first and last plate in configuration 1 and first and last plate in configuration 2. So first of all we have to determine the charge distribution, what charges are appearing on various plates. So for this a very simple formula which I have explained in my previous video, and I have also given the link in the description. You can watch it. Is a very long video, but conceptual one to understand why something means this charge distribution is occurring. Here I have given directly the charge distribution. So the charge on this last plate, suppose I am writing it as A and this B. So charge on first A and B, in both cases, will be sum of all the charges divided by 2. So what will happen is plus sigma minus sigma plus sigma minus sigma plus sigma minus sigma. So the total value is 0. So this divided by 2 is also 0. So charge on extreme left plate will be 0. Similarly, charge on extreme right plate will also be 0. Now, we have determined charges on the faces that are appearing on extreme left and extreme right. Now coming to this one, from charge conservation, initially this plate has a total charge of plus sigma. So a plus sigma charge will also appear on this face. Now, considering that the electric field, this is plus sigma. Now, using Gauss law and considering electric field here to be 0, what a simple thing comes out is that equal and opposite charges will appear on the opposite faces of the plate. So here it will be minus sigma. Similarly, since this plate has a total charge of minus sigma 0, so here charge of 0 will appear. Likewise, here there will be no charge. From Gauss law and electric field within this point to be 0. And from charge distribution, again this will be plus sigma. Similarly, opposite faces will have minus opposite charges, charge distribution, so that electric field at this point is 0. Likewise, since total charge is minus sigma, so here it will be 0. Now again, here this by charge equal and opposite, it will be 0. And from conservation of charge, this face will have plus sigma. And again, from conservation of from Gauss law and electric field having value 0 at this point, this should be minus sigma naught. So now once the charge distribution is known, what we have to find out, this is our region 1, this is our region 2, this is our region 3, and this is our region 4, and this is our first configuration. So in region 4, what we have to do, we have to find the electric field, which is sum of means like because of the charge distribution appearing on opposite faces, the electric field will be, this has a 0 charge distribution and this is also 0 charge distribution. So electric field in this region 4 will be 0. Now please remember that electric field is a vector quantity, and all these charges plus q, minus q, etc., they will have a net field here, but these net field, they actually cancel out, and what appears for the electric field is the charges appearing on the opposite faces. That is what is required, and the net electric field is if the charge distribution is sigma, suppose, then it is sigma by epsilon naught. Now coming to configuration 2, this is our configuration 2, and we have to find electric field in the region. Suppose this is our region 1, this is our region 2, and this is our region 3. So we have to find the electric field between these two regions, in region 3. So this electric field will be sigma by 2 and by 2, that is 4, sigma by 4 epsilon naught. So this is the net electric field in region 3. So the option B is not correct. Now coming to, we have to find the potential difference between first and last plate in configuration 1. So moving back to configuration 1, this is our configuration 1. So in these potential difference between 1 and 2, or between these two, is sigma by epsilon naught into d, because we have sigma by 2 epsilon naught, and then again sigma by 2 epsilon naught, that will be sigma by epsilon naught. So potential difference between these two plates will be sigma by epsilon naught into d, and this value comes out to be 1 volt. So this is 1 volt plus 1 volt. In this case there is no electric field, so no drop. This is 0. This is again plus 1 volt, and this is 0, and this is again plus 1 volt, the last one. So the net potential drop from first to last will be 1 plus 1 plus 1, that is potential drop in this case will be 3 volt. So finally potential drop will be 3 volt from first to last in configuration 1. Now coming to configuration 2, in this case we will use the same formula. So potential drop in this case will be sigma by 2 epsilon naught into d, that is 0.5 volt, and in the second case it will be minus, because we have minus sigma by 2 and plus sigma by 2, so this will be minus. Likewise we have plus 0.5, and then again we have minus 0.5, and the last one is plus 0.5. This is minus 0.5, and last one is plus 0.5. So net potential drop from first to last plate will be, if we add, these two will cancel out, again these two will cancel out, so net potential will be 0.5 volt between first and last plate for the second configuration. Now coming to our answer, what are the correct answers? So moving to our question, in region 4 electric field is 0, this is correct, so this is correct. In region 3 this is not correct, because it was found that it was sigma by 4 epsilon naught. Potential difference, this is not correct, because the potential was found to be 3 volt, and in fourth case, that is potential difference between these two, first and last configuration, first and last placed for plate for the configuration 2, this was coming out to be 0.5, so this is not 0, and this, so this is not correct. So final answer is A. Thank you.